It is now time to make the calculator function actually work, or calculate function actually work, rather than just returning the key. So we're going to figure out how we want to do this, and my first bet is that since we already have the key and we already know, that's going to determine if it's adding or subtracting, so we don't need to worry about encoding or decoding. All we have to do is accept text and then change that text. So I'm going to ask the user for the text that they want to encode, and I'll put that into a variable titled user text, and that's going to be string input text. I don't want to be any more specific than text. I don't want to say text to encode or decode because it could be either one. And then what we have to do here is, so I guess right off the bat, let's make it work for just one letter at a time. And then from there, I'll make it more complicated. But by the end of this video, I want to make the code work with just one letter. So what we'll do is get a new number. So I'm going to call this a temp num. It's a temporary number to represent the user text in its current form as a letter or as a number. So to do that, we type in ord of user text. And so if it's one letter, then that's going to give me a number out. And now temp num is going to be the number that we want, or that we had. And temp num, I'm now going to add the key to it. So that's another way of writing temp num equals temp num plus key. It's a shorter way of writing it. So now I'm going to change it, and I'm going to change it. So now I added or subtracted the value, and now I'm going to add it or turn it back into a letter. And to do that, I'm going to now say that user text, I'll reuse that variable. I'll say user text equals and its chr is the function for this. So we're going to pass through the new temp num value. And so what that does is we have a letter, we get it, we turn it into a number, we increase that number by the key value or decrease it by the key value, and then we set the variable that we originally used to accept input equal to the letter that we now have given the number that we changed. So the last thing we have to do is return that. And so I'll separate that from everything else. Return user text. And I think, yeah, because we're going to print it. Awesome. So I believe that should work if I run it. Let's try it out. Encode. Let's do 2. That's easy to check. I just want to enter the letter A. They tell me that it's C. Awesome. My code says C. So maybe we'll return something. Maybe what we'll return is we'll return encoded like that. Comma to make it more obvious that that's the output. Encoded, or that's going to be decoded. Whoops. Decoded, comma. All right, let's try this one more time. But it worked. We got, it output C when we entered in A. So let's decode and do the same thing. A K value of 2. We got we got C, so it should enter A decoded. Awesome, it worked. And that's how it works for one letter. Next, we're going to make it work for actual strings. Now what I would like to do is make the code, make my program encode and decode full strings instead of just one letter. And so this is where it gets a little bit more complicated. So far, most of our code has been print statements, if and else statements. We've been creating functions to decompose the problem, and in the last video we used ord and chr, those weird methods or those weird functions that helped us get from letters to numbers. But now we're actually going to be introducing the first newer concept, which is going to be a loop. and specifically we'll be using a for loop. So I have a separate video on loops, which I may have posted already, but I'm not exactly sure where I am in terms of my editing right now for my videos, but I'm going to go through the for loop as though it's something you understand. If you're confused, look out for the for loop video, but the basic structure of a for loop, so loop through every letter, to loop through every letter of a word, you can simply type for letter in, for instance, user text. And so what we're going to do is, what that does is all the code that I put indented in now, right here, 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 and so on, all of that is going to loop for every letter inside user text, and it's going to create a variable called letter that's equal to each of the letters. So I could have called this anything, A, I, whatever. I normally use I if it's an index, if I'm keeping track of a number, like 0, 1, 2, 3. And I'll spell it out and say it's a letter if I'm getting letters from a word, just so that I know. As I read it in my head, it makes sense to me. So for each of the letters, we're going to do this. And I don't want to comment it out, but boom, there it is. Tab, tab. And so what I need to do, though, is I need to keep track of, so I need to make temp num equal to ord of letter, and then finally what I'm going to do is, instead of adding it back to user text, we're going to have another variable now. I'm just going to call it maybe response. I'll call it answer equals, and it's just going to be an empty string for now. So it has nothing on it, and what I'm going to do is I'm going to slowly add to it. Answer plus equals whatever the temp num has been once we've done our changes to it. So the only way I'm changing this code is the exact same as it is above, except I have an answer variable now. In addition, I'm looping through each of the letters, and I'm getting a letter variable for each. So I'm doing ord onto letter, not directly onto user text. I basically only accept user text and then cycle through it. That's all I do. And I basically compose answer from nothing. It's an empty string, and then I add each of the letters individually to it. So that might work on its own, and I want to try that. So choice, I want to encode, and k-value, I'm going to make 3. Text, metatutor. All right, so there we have it. That disgusting thing. So now let's decode. K-value is 3, and then I'll paste that, and boom, it works. Or at least it's wrong in exactly the same way that it is right, and I'm fine with that. And so yeah, that will work for some basic words. I will point out, though, that I immediately am aware that it's not perfect. For instance, if I were to say encode, and I were to put k-value of maybe 50 for any text, it's going to give me something weird. So ABCD, yeah, it didn't even print. Maybe if I do 20 and I do ABC space D, I'm going to get, yeah, I got a number in there. And I shouldn't be getting that. That's for the space, granted. That is because of the space. But I think that if I do maybe like a k-value of 1 and Z, yeah, it's going to print a bracket. And that's weird. So we can make it so that it doesn't print, stuff that it's not supposed to. But the main reason why that is because the ASCII table that I mentioned earlier doesn't just provide numbers for letters, it also provides numbers for basically anything else that you can represent on a keyboard. So for instance, a space is the number 32. As we just found out, whatever Z is, I'm not 100% sure what it is, but maybe, let's say it's 100 and, I'm going to guess, I think it's 124. No, that doesn't make sense. Anyway, I'm just going to say it's 124. We now know that a bracket, I think it was an opening bracket, I forget. We know that a curly brace like that is 125. We can just add 1 to Z. And so we can actually find out what the rest of the table is, but you can also Google it and see what they are. So the final thing that we will have to do, right now we can confidently say, okay, this works, but the final thing that I would like to do is I would like to look back at my code, and I'd like to see if I can find a way to see, okay, if it's greater than, if the number goes greater than whatever Z is, we somehow have to set it back to A. And so that'll be the final bit of code that I write, but I'm going to release that video in the future. That's not something I care about right now. Thank you for watching.